Hey guys, welcome back. We are on chapter 3 now and applications of differentiation. So I was thinking really hard about how to introduce this chapter, and so I think I have a really nice way of showing you what this chapter is about, okay? So this chapter is about increasing functions and decreasing functions and on what intervals they are increasing and decreasing. And are there any maximum values or minimum values? And is the function concaved up and or down on a certain interval? Can we find how do we maximize a box or the print on a book? So this chapter actually shows us how to apply all the derivatives. So I'm going to begin with a lot of examples, and then in our next video I'm going to show you the mathematics behind it. Right now I have all of these pictures and we're just going to answer some simple questions, okay? So I drew this line and I said this line is y equals 3/2 x plus 2. It starts at 2 and it has a positive slope. This function is constantly increasing, okay? It's constantly, you see how it keeps just going up, up, up. And there is no maximum or no minimum value. You guys see that? Every time you think you have the highest point, there's going to be a higher point, and so on, okay? That was simple. Now, this function down here is y equals negative 1/2 x plus 3. This slope is negative. It means the function is constantly, not costly, constantly decreasing, and there is no maximum or minimum value. This function is constantly decreasing, okay? You guys see that? And there's no maximum or minimum point. So this slope is positive and this slope is negative. Moving on to a parabola. Well, this parabola, as you guys can see, is decreasing. Okay, and now let me show you here. This is -1, -2, -3, -4, 5, so on. -1,000,000 is all the way over there. So we call that, let's say, negative infinity. So from all the way back here, okay, this parabola is decreasing. You see how the slope is sort of negative? If I was just gonna not make it curve, the slope is negative. This is a negative slope. So the parabola, it's decreasing from negative infinity to x equals 3, right? But we don't actually close the interval of 3. So we say it is decreasing. I'm just going to put d negative infinity to positive 3, and we make sure that it's an open parentheses, okay? And then it's going to be increasing from 3 all the way to positive infinity. Okay, so it's going to be increasing from 3 to positive infinity. Now, guys, if you go from a decreasing to an increasing, you're going to hit a low, right? Right now, we can tell that there's a minimum at 3. So we say there's something called a relative minimum, and it's going to be at x equals 3. Now, most AP questions or calculus courses, they'll tell you at x equals, sometimes they say, what is the minimum value? And that minimum value is, they're referring to the y, so that's 2. Sometimes they might say at what point, and then you would have to say 3, 2. So guys, when the function is decreasing and then increasing, there's going to be a minimum, just like I showed you in this picture. So let's take a look at the next example below. In this example, the parabola is increasing. See how it keeps going up? But it doesn't go up all the way from negative infinity to positive infinity, right? It's going to go up from negative infinity to x equals 2. That's where it's increasing. Then it goes down from 2 to infinity. See how it's going down now? The y values are getting less and less into the negatives, right? So it's decreasing. Well, guys, when you go up and then down, it hits a max. Think about climbing a mountain. If you climb a mountain and then you come back down, you hit at some point the highest. So there's something called a relative max at x equals 2 in this case. If you want the value, then you must give them the y. So that's 1, that's 2, that's 3, that's 4 at y equals 4. So just be careful with the wording, okay? Now let's take a look at this example. So can you guys pause the video and ask yourself where it's increasing, decreasing, what's the max, what's the min, if it's concave down, concaved up? Okay, you guys pause the video and then unpause it and I'm back. Great. I am increasing here to here I go up. So I'm going to increase from negative infinity all the way to 3. Is that the only place? No, guys, right? You guys see how I increase up here as well, right? So what we do is we make sort of this guy right here like a U for a union, okay? And we're going to do 3 to infinity, okay? So those are my two answers. And now where's it decreasing? I hope you guys guessed right. It's decreasing from 3 all the way to 5, right? So we're going to do 3 to 5, okay? Now, where's my max? Well, you're looking at it. It's right here. My max is at x equals 3. Where's my min? At x equals 5. Okay, so typically what we're going to do is we're going to draw a number line just like this, and I'm going to show you this in the next video. And we're going to put 3, and we're going to put 5, and we're going to call this guy right here f prime, which I'm going to show you next video. And then we go, oh, it's increasing all the way here, decreasing, and then increasing, right? And then I'm going to say, oh, if it goes up, then down, there's a max. You see how it matches? And if it goes down negative to positive, then that's a minimum. And just to sort of introduce you for next video, if you see this f prime represents a derivative. Derivative typically refers to a slope. If you take the look at this graph, this is a positive slope. Isn't that right? This is a negative slope. This is a positive slope. And that's why I call this f prime, and that's why I say, hey, it's positive up to 3, negative in between 3 and 5, and then positive at 5. So we're looking at these slopes, okay? Now, you might ask, what about this concave down, concaved up? Now, guys, once again, this is an overview of all 9 sections. This is really about 3 or 4 sections, so don't get nervous. Just make sure you watch all the videos. Here's my last part, concave down, okay? So let me see if I can get rid of a lot of this stuff, sorry. Okay, so we're gonna take a look at this here. I think that's good enough. And I'm going to grab a purple highlighter. This is concave down. It's such a sad face, okay? Now, I'm going to switch over to a happy face. See? So, I don't really know how far I'm going to be concave down. So I'm going to say it's from negative infinity to some number. I don't know. And then from that number to positive infinity. Now, in about 4 videos from now, I'm going to teach you how to find this number. And you're going to have to find it using some algebra and some derivatives. But guys, this number where it switches from the concavity is called the point of inflection. And you might see it POI, okay? So I'll teach you all that stuff. So this chapter is about increasing and decreasing, about concaved up, concave down, maxes and mins, and points of inflection, along with optimization. Okay, so I just want to remind you guys of one thing, and this will help you for next video and so on. This is a positive slope. This is a negative slope. This means it's increasing. This means it's decreasing. When you guys have something that has a curve, like a parabola or maybe a cubic or whatever, treat it like straight lines even though they're curved. So this has a negative slope up to here. Then it has a positive slope. This has a positive slope up to there, then a negative slope. That's how you know if it's increasing or decreasing. This has a positive slope. That means it's increasing all the way there. Then it has a negative slope. That means it's decreasing. Then it's increasing. Okay? So you might say, well, I can just look at the picture and find the maximum and min and where they... Well, what if I gave you something that looks like 3x to the third minus 4x squared plus 4 radical x? Well, you can't just look at the picture. I mean, you can use a calculator and it'll find it, but I'm going to show you how to, I'll show you how to figure it out using some derivatives. If I gave you this, you're not going to know where the max, min, concaved up. I'm going to show you how to do that using some derivatives. But think about this before we get started in our next video. The derivative tells you slopes of tangent lines, right? The derivative tells you slopes. If you know the slope is increasing, then decreasing, I have a maximum. If you know the slope is decreasing, then increasing, I have a minimum. And that's all. So we're going to have to find derivatives, set them equal to 0, and then figure that stuff out. Okay, so I'm going to stop this video now, and I hope everybody watches it. And let's go on to the next video, okay? Have a great day.